Using the generating function of Pn of x, prove that n into Pn of x equal to x Pn dash of x minus Pn minus 1 dash of x. The generating function of Pn of x is given by 1 minus 2 xz plus z square power minus of equal to summation n equal to 0 to infinity z power n into Pn of x. Consider this is equation 1. This is the generating function of Pn of x. Differentiate equation 1 with respect to z. We can get minus 1 by 2 1 minus 2 xz plus z square or minus 3 by 2 into minus 2x plus 2z. Here n into z power n minus 1 Pn of x. There is x minus z into 1 minus 2 xz plus z square or minus 3 by 2. Just take minus 2 outside. If you take minus 2 outside, this is treated as x minus z. Minus 2 into minus 1 by 2 is 1. Therefore, this is reduced as x minus z into 1 minus 2 xz plus z square power minus 3 by 2. This is n into z power n minus 1 Pn of x. This is equation 2. Further, differentiate equation 1 with respect to x. We can get differentiate this equation 1 with respect to x. It is minus 1 by 2 1 minus 2 xz plus z square or minus 3 by 2 into minus 2z. We are differentiating with respect to x. So, differentiation of minus 2 xz is only minus 2z, which is equal to, write down this z power n as such. Here n equal to 0 to infinity, then Pn dash of s. This is equation number 3. Now, this is modified as z into 1 minus 2 xz plus z square power minus 3 by 2. Here, minus to minus plus 2 to get cancelled. So, z into this term, which is equal to z power n Pn dash of x. This is equation 4. Now, find out 2 by 4. From this, equation 2 divided by 4. Equation 2 divided by 4 implies x minus z divided by z. These two terms, 1 minus 2xz plus z square power minus 3 by 2, then divided by 1 minus 2xz plus z square power minus 3 by 2 cancelled out. So 2 by 4 implies x minus z divided by z, which is equal to n into z power n minus 1 Pn of x 4 divided by z power n Pn dash of x. This is the value of 2 by 4. Now we have to modify this further. Just by means of cross multiplication we have to simplify this. X minus z power n Pn dash of x, which is equal to n z, then z power n minus 1 into Pn of x. This is modified as x z power n Pn dash of x minus z power n plus 1 Pn dash of x. X into z power n Pn dash of x minus z power n into z power n equal to z power n plus 1 Pn dash of x, which is equal to n into z power 1 into z power n minus 1 is z power n Pn of x. Now we have to convert all the powers of z in terms of z power n. Double equation. Here the first term is carrying z power n, so write down as such. The second term z power n plus 1 is present. So that replace n by means of n minus 1, because if n equal to n minus 1, then n plus 1 is n minus 1 plus 1 equal to n. We have to express all the terms of z in terms of z power n. Therefore, this is z power n p dash of n minus 1 of x. Here n into z power n into Pn of x. Now we have expressed all the terms in terms of z power n. Consider this is equation number 5. On equating the coefficient of z power n, on equating the coefficient of z power n, we get here x into Pn dash of x. Here n into Pn of x. Write on that term first. N into Pn of x, which is equal to x into Pn dash of x minus Pn minus 1 dash of x. Here is n into Pn of x, here n into Pn of x, which is equal to x into Pn dash of x minus Pn minus 1 dash of x. Hence the required is right. Using the generating function of Pn of x, we have proved the result.